Welcome, this is Professor Ridge and today's lesson 4.1, Linear Functions. And our first learning objective, represent a linear function. Representing linear functions. A linear function is defined as a function with a constant rate of change. It is a polynomial of degree 1. So here's the definition. A linear function is a function whose graph is a line. So if you graph it, the graph's going to be a line. Linear functions can be written in the slope-intercept form of a line. And remember, the f of x is y. So f of x, or y, equals mx plus b. This is called the slope-intercept form, where b is the initial or starting value of the function. Or if we're thinking of the graph, it is the y-intercept 0b. Okay? So b is the initial starting value of the function when the input x is equal to 0. So if x is 0, y is going to be b. M is the constant rate of change, or the slope of the function. So m is that constant rate of change, and we call that the slope. Change of y over change of x. Example 1. Using a linear function to find the pressure on a diver. The pressure P in pounds per square inch, PSI, on the diver in figure 4, you can refer to the book for that one, depends upon her depth below the water surface D in feet. This relationship may be modeled by the equation P of D is equal to 0.434 D plus 14.696. Restate this function in words. So again, there's several ways that we can represent a function. We can do it in words. We could do it as a function equation like this one. We can do it as a graph. So here, restate this function in words. So again, basically the way you read it, it'd be P is pressure. Pressure as a function of depth is equal to 0.434 or 434 thousandths times the depth plus 14.696. And again, just to kind of restate this, this number 14.696, that's the initial pressure when the depth is 0. And then for every change of 1 foot of depth, you're going to increase the pressure by 0.434. Okay, 434 thousandths. On to the next learning objective. Determine whether a linear function is increasing, decreasing, or constant. Determining whether a linear function is increasing, decreasing, or constant. So it's basically just like we did with any old function, not just linear, is as you move from left to right, if the y values are going up, the function would be increasing. So this function would be increasing. So we would say that has a positive slope. This one, as we move from left to right, the y values are going down. So that's decreasing. And then this one is not going up or down, so that one, the function's constant, and the slope would be equal to 0. So I'm going to write that down. So here the slope, and typically we use m for slope. So if it's increasing, the slope is positive. And then on this one, the slope is negative. And then on this one, the slope is 0. Okay, and that's summed up in this graphic right here. If the slope is increasing, if the function's increasing, then the slope is positive, right? Greater than 0 is positive. If it's decreasing, then the slope, m, is less than 0. And if it's constant function, it's not going up or down, the slope is equal to 0. Example 2, deciding whether a function is increasing, decreasing, or constant. Studies from the early 2010s indicated that teens sent about 60 texts a day. while more recent data indicates much higher messaging rates among all users, particularly considering the various apps with which people can communicate. For each of the following scenarios, find the linear function that describes the relationship between the input value and the output value. Then determine whether the graph of the function is increasing, decreasing, or constant. Okay, so A, the total number of text a teen sends is considered a function of time in days. The input is the number of days, and the output is the total number of texts sent. So that one we would probably say, let's see here. Okay, so we want to find the linear function describes the relationship between input and output. So we're going to do our function of x. X is going to be the time in days, and y is going to be the total number of texts. Okay, so we're going to have so if we do 60 texts per day, it'd be 60x. And then that function would be increasing, right, because that's a positive 60. Okay, B, a person has a limit of 500 texts per month in their data plan. The input is the number of days, and the output is the total number of texts remaining for the month. So here our f of x is going to be the remaining number of texts. So if you get a 500 total, so day 0, you're going to have 500 texts, right? That'll be your y input. And then we're going to subtract 60 times x. So after 1 day, you have 500 minus 60. After 2 days, you'd have 500 minus 60 times 2. Or if you want to write this with the mx plus b form, you can just write the minus 60x plus 500 like that. Okay, and again, this would be a decreasing function because m is negative. So this, if I graph it, it'll be going down as you move from right to left. All right, and then C, a person has an unlimited number of texts in their data plan for a cost of $50 per month. The input is the number of days. The output is the total cost of texting each month. Well, it says it's unlimited, so it doesn't matter if you send out 1 text, 1,000 texts, 1,000,000 texts. It's just going to be a flat $50 for the month. Okay, so it doesn't matter how many you send, so there's not going to be any x, and this would be a constant function. Okay, I just wrote, it said determine whether the graph's increasing, decreasing, constant. I did mention it, but thought I should write it. So again, this is a positive slope, so it's increasing. This is a negative slope, so it's decreasing. And this slope's 0. It's 0x, and it's constant. The next learning objective, interpret slope as a rate of change. Interpreting slope as a rate of change. So m equals the change in output, that's called a rise, or change of input, that's a run. So remember, if we're going, output is the y-axis in this case. So change in y is the change in output, and you're going to subtract the y-coordinates. And then the change of input, the run, that's the x-axis going side to side. And we put delta x, or we can read it as change in x. So again, that's the Greek letter delta. So delta y, delta x. And we can also read it as change in y, change of x. Okay? So we're going to subtract the y coordinates for our change in y and subtract the x coordinates for change of x. So if I wanted to find the slope between these 2 points, this is 2, 1. There's a couple ways you can do it. If I have it on a graph like this, I can say, all right, going this way, that's my change in y. And then going this way, that's going to be my change of x. So this is my rise over run. So I can count 1, 2, 3, 4. So that's 4. Then I can count 1, 2, 2. So one way I could do it is if it's on a graph, I can just count the rise over the run. Rise over run is rise was 4, run is 2, 4 divided by 2 is 2. So you can leave it as a fraction, 2 over 1, or you just leave it and write it as 2. Either way, it's fine. If I figured out this point, this is 2, 1, and this point is 4, 5. I can use the formula that's given here. I'm going to subtract the y coordinates, subtract the x coordinates, and then divide those two. Rise over run. So y2 is 5, y1 is 1. So 5 minus 1. And then x2 is 4, x1 is 2. So 4 minus 2. And you have to do it in the same order. So you could switch this to be y1 minus y2, but then you got to switch the bottom as well, x1 minus x2. I tend to just do it this way always, but you can switch them as long as you switch both of them. So 5 minus 1 is 4, 4 minus 2 is 2, and you see we get the same answer as above. So you can do it either way. If you have the coordinates, you can plug it in the formula. If it's on a graph and you can count rise over run, you can count it. So either way. Okay, let's try example 3, finding the slope of a linear function. If f of x is a linear function and 3, negative 2 and 8, 1 are points on the line, find the slope. Is this function increasing or decreasing? Alright, so we're going to use the formula that we did in the previous example. So our slope is going to be y2 minus y1 equals x2 minus x1. So remember, it doesn't matter which one you call point 1 and point 2, by the way. So usually the first one's point 1 for me. Second one would be point 2. Oops, that would be y2. Okay, so 1 minus a minus 2, which becomes 1 plus 2. And then 8 minus 3 for the x's. So 1 plus 2 is 3. 8 minus 3 is 5. So the slope is 3/5. And then that's positive, which is greater than 0, right? It's positive. So then that means the function is increasing. So it's going up as we move from left to right. Example 4, finding the population change from a linear function. The population of a city increased from 23,400 to 27,800 between 2008 and 2012. Find the change of population per year. If we assume the change is a constant from 2008 to 2012. So we want the change of population per year. So look, this is going to help me figure out which one's x and which one's y. So population per is the divided by. So remember, I'm doing change of y over change of x. So x's are going to be years and population will be y's. So we're going to have 2 data points. So in the year 2008, there was 23,400. I'm not going to put the comma there just so I don't confuse myself. So x is 2008, y is 23,400, and then point 2 would be the next data point. 2012 is the year. Remember, x is year, y is population. And the population 2012 was 27,800. So my slope, my rate of change is slope, which is equal to y2 minus y1 over x2 minus x1. So 27,800 minus 23,400 over 2012 minus 2008. So that would be 4. That would be 4,400, which equals 1,100. Oops. 1,100 people per year. Okay, the next learning objective, write and interpret an equation for a linear equation. Example 5, writing an equation for a linear function. Write an equation for a linear function given the graph of f shown in figure 8. Okay, so how to? Given the graph of the linear function, write an equation to represent the function. So identify 2 points on the line. Use the 2 points to calculate the slope. Determine where the line crosses the y-axis to identify the y-intercept by visual inspection. And then substitute the slope and y-intercept into the form of the line. So if we write this as y equals, or f of x equals mx plus b, to write the linear equation to represent this line as a linear function, we need to know 2 things. We need to know the slope. We need to know the y-intercept, the y-coordinate of the y-intercept. Okay, that's the easy one. You can look, it crosses the y-axis at 2. So here we got a point 0, 2. And then also you can, back here, identify 2 points in the line. Well, I always identify the y-intercept. If it's on a nice crosshairs, if it's at a fraction, I'm going to look for 2 points that hit the crosshairs for an x and a y. So this one would be 2, 8. Okay, so our first step then is figure out what slope is. So slope is, remember, y2 minus y1 over x2 minus x1. You can also count like I mentioned before. So this is up 2, 4, let's see, up 2, 4, 6, and over 2. So our slope is, so you can do it either way. So the way the book's listing here is they want you to use the slope formula. But we can count. 2, 4, 6 is my rise. My run is 2. So 6 over 2, which is going to be 3. If I do it with the formula, the way that it's mentioning up here, 8 minus 2 over 2 minus 0. So 6 over 2, which gets us 3. Now, the only drawback of counting is you just got to remember, if you're going up as you move from left to right, it'll be a positive slope. If it's going down, it'd be a negative slope. If you use the formula, when you work it out, you'll get positive or negative without having to look at the graph. You can just, if it's positive 3, it's positive 3. If it's negative 3, it would be negative 3. All right, so we calculated the slope. Now determine where it crosses the y-axis, which we did, 0, 2. So 2 is the b. This is going to be our b. So b is equal to 2. So if you have the graph and you see it crosses the y-axis at 2, the y-intercept is 0, 2. B will be the y-coordinate of the y-intercept. So it's just the 2. So now we're ready to plug in both of these numbers into the general form up here, the slope-intercept form. So the slope is 3, and then you put the x, plus b, b is 2. And it's simple as that. Example 6, writing an equation for a linear cost function. Suppose Ben starts a company in which he incurs a fixed cost of $1,250 per month for overhead, which includes his office rent. His production costs are $37.50 per item. Write a linear function C where C of X is the cost for X items produced in a given month. All right. So this is our total cost to produce, say, 100 items or 200 items or 0 items. You're always going to put in your fixed costs. So whether I do 1,000 items or 1,000,000 items or 0 items, I have to pay my rent. I have to pay all the fixed costs associated with having that company or that store or whatever it is. Okay, so that's going to be our fixed cost. Plus or variable costs, or the cost per item, right? So basically our fixed cost is the $12.50. The variable costs per item, and the per item, that's going to be X. So it's going to cost us $37.50 times the number of items we produce, and then that's basically it. That's our formula. So you can write it this way. That's pretty typical that you put the fixed cost first for these kind of equations, or you can do it the mx plus b, so it'll be $37.50 plus $12.50. Oops, don't forget the x. That's a common mistake. So x plus $12.50. Write an equation for a linear function given 2 points. If f is a linear function with f of 3 being equal to -2 and f of 8 equal 1, find an equation for the function in slope-intercept form. So remember, our slope-intercept form is f of x or y equals mx plus b. So we can do it with the y or f of x. It doesn't matter. You can interchange those two. So technically they give us as a linear function. We probably should write it this way, but again, it doesn't matter. You can interchange the f of x and y. Now, from the previous problem, I told you there's to write an equation in slope-intercept form, we need 2 pieces of information. We need to know the slope, we need to know m, we need to know the y-coordinate of the y-intercept. Where is it across the y-axis? So we need those 2 things. Here they just gave us 2 points. They gave us 2 function values. So remember, this is your x, so when x is equal to 3, f of x, which is y, is equal to -2. Okay, so that we have that point. Okay, so again, we have this point, f of 3 is -2, so we can rewrite that as f of 3 equals -2 is the same thing as saying x is 3 when y is -2, and then f of 8, so this will be our second point, is the same thing as saying x is 8 when y is 1. So now to find my slope, I'm going to do y2 minus y1 over x2 minus x of 1. Okay, so plugging in the numbers, let's see, y, we'll call this point 1, point 2, so 1 minus a minus 2 over 8 minus 3. So you get 3 over 5. So your slope's 3/5. So now we have m is 3/5. Now, we don't have b. We don't know b yet. We're just going to write this with the y. It makes it a little easier. Okay, so what you do is you take either point, the x and y. So again, this is x, this is y. So you're just going to plug in x, y. So you can plug in 8, 1, or you can plug in 3, -2. It's up to you, whichever one works better. you'll get the same answer. So let me plug in the 8, 1, so that way I don't have a negative there. Okay, solve this for B now. So now we're going to solve it for B. So we do, think of this as 8 over 1, so it'll be 24/5 plus B. We're going to solve it for B. Minus 24/5. So remember, 1 is the same thing as 20. We want fifths. So, oops. 1 is the same thing as 5 over 5. So 5 minus 24, you subtract, take the sign of the bigger, so it'll be minus 19/5. Okay, now we have our two pieces of information. We have the M, which is 3/5. We have the B that we just figured out is the negative 19/5. So our equation in slope-intercept form would be y equals M, which is 3/5, x, plus B, which is negative 19/5. And that is our final answer. Modeling real-world problems with linear functions. Given a linear function f and the initial value and rate of change, evaluate f of c. Determine the initial value and the rate of change, which is the slope. Then you're going to substitute the values into the equation, f of x equals mx plus b, and evaluate the function at x equals c. Alright, so let's look at example 8 here. Marcus currently has 200 songs in his music collection. Every month he adds 15 new songs. Write a formula for the number of songs in his collection as a function of time. Function of time t, and which is the number of months. How many songs will he own at the end of 1 year? Okay, so our determine initial value, rate of change. So our initial value is going to be 200 songs. So that's our B. And our slope, or rate of change, is 15 new songs per month. So that's our M. 15 songs per month. Okay. Write a formula for the number of songs in. So n as a function of time is equal to, so remember our slope is 15 songs per month times t is the number of months, plus our initial value, which is 200. So that's our formula. And then how many songs will I own at the end of 1 year? So assuming that this is the beginning of the year, we have 200. So if we want to find 1 year is 12 months, so 15 times 12 plus 200, that will equal, let's see, 180, 380 songs by the end of the year. Example 9, using a linear function to calculate salary based on commission. Working as an insurance salesperson, Ilya earns a base salary plus a commission on each new policy. Therefore, Ilya's weekly income I depends on the number of new policies in which he sells during the week. Last week he sold 3 new policies and earned $760 for the week. The week before he sold 5 new policies, earned $920. Find an equation I of n and interpret the meaning and the components of each equation. So this is our output, I of n. That's the weekly income for the number of policies he sold. Inputs n. So m for my slope. And then I'm going to do B would be his base, right? So we have two data points here. Last week he sold 3 policies and earned $760. So if I of 3 is $760, so again that would be like 3 $760 for the point. And then the week before that he sold 5 and earned $920. So that'll get us 5 $920. So now we got to figure out the slope, which is basically the commission per policy. Okay. So if we do M is Y2 minus Y1 over X2 minus X1, we get 920 minus 760 over 5 minus 3 equals, let's see, that would be 160 over 2, which is $80 per policy. Okay, now we need to know B. So again, just like before, let's see, we're going to do I of N is equal to $80 per policy times the number of policies plus B, which would be their base salary, plus your $80 per new policy for the commission. All right, so let's plug in one of these two numbers. Doesn't matter which. We'll do the 760 for the 3 policies to figure out what our base salary is. So 3 times 80 is 240. Subtract 240 from 760. Subtract it from both sides. So B is equal to, let's see, $520. So that's our base amount. And then the commission. So our formula is going to be I of N is going to be 80 N plus 520. Is that all we wanted here? Interpret the components. So again, N is the number of policies we sell, 80 is the commission for each new policy, and 520 is the base salary. Example 10, using tabular form to write an equation for a linear function. Table 1 relates the number of rats in a population to time in weeks. Use the table to write a linear equation. Okay, so number of weeks is W. So 0 weeks, so we start out with 1,000 rats. 2 weeks is 1080, 4 weeks is 1160, 6 weeks is 1240. So let's see, we want to write a linear equation. All right, so we need to find the slope. So look at, it's growing by 80 each of these things. So you can kind of see that, or you can, again, you can just think of it as 2 points. We got 4 points, but just pick 2 points and then just subtract between, just find the slope. Y2 minus Y1, X sub 2 minus X sub 1, 1080 minus 1,000 over 2 minus 0. So it'll be 80 over 2, which is 40 rats per week. All right, so now we know M, and then we have B right here. We don't have to actually plug it in the formula. So our formula is going to be P of W is equal to 40 rats per week times the number of weeks plus our starting amount, which was 1,000. And that's our equation. And that's all they asked for, right? On to the next learning objective, graph linear functions. Graphing linear functions, graphing a function by plotting points. So there's a few ways we can graph a line. The most basic way is just picking numbers, plotting points, right? So the technique is, first you're going to choose a minimum of 2 input values, evaluate the function at each of those input values to find the output value, use the resulting output value to identify the coordinate pair. So we're basically finding 2 points. Plot the coordinate pairs on the grid, and then draw the line through the points. So geometry, we know 2 points determine a line, and then you can draw the line through it. So for instance, if I were to put a point right here and a point at, say, 5, 2, that determines a line, and then I can draw the line through it. Okay, now that's not the line that we want here. I'm just showing you that if you have 2 points, you can draw a line through those 2 points. So the idea then is let's figure out what those 2 points are that satisfy the equation f of x is equal to negative 2/3 x plus 5. I personally like you to do 3 points. So negative 2/3 x plus 5. Because the third point is the check. Okay, so if I always do 0. Now since this is a fraction, I want to pick something that will cancel the fraction. So I can do like 3 and 6. Because that will cancel the fraction part. Or if I want to do a negative one, I can do like negative 3. If I want to do 4 points, I would go to 6. So when I plug in the x, this is 0 plus 5 will get me 5. So my coordinate pair would be 0, 5. So I put a dot at 0, 5. So that's 1 point. Now I'm going to do another point. So here the 3's cancel. And I got negative 2 plus 5, which will be 3. So I have the second point, 3, 3. So technically that's all I need is the 2 points to draw the line through it. And I'm done. I go to the next problem. Right? But if I want to do a third point as a check, just to make sure I didn't make any what I call silly math errors, you know. So when I was adding this negative 2 plus 3 and I put, you know, something that was wrong, right, I wouldn't catch it over here. So if I do a third point, oops, so negative 2 over 3 times negative 3 plus 5. So the 3's cancel and negative make positive 2 plus 5, which would be 7. So negative 3, 7. You can see that's on the line there. It's off a tiny bit because it looks like I'm off just a little bit. But anyway, and then that would be another reason to do 3. You can make your graph a little bit more accurate. Okay, so again, this is the most basic way of graphing a line. You pick numbers for x, plug them in to the equation, solve it for y, take the ordered pair, the x, y, plot it, and then do it again. And then I suggest doing 3, right? Technically you only need to do 2, but you should do at least 3. Graphing a function using y-intercept and slope. So this is the most common way to graph a line, right? You could do the technique we just talked about, plotting points. But if it's a linear equation, you have it in slope-intercept form, this is the quickest way to graph a line once you understand it. So the technique is you evaluate the function at an input value of 0 to find the y-intercept. So when you plug in 0 for the y-intercept, remember y-intercept is where it crosses the y-axis. So you plug in 0 for x to be on the right here at the origin, and then the y tells you where on the y-axis the line's going to cross. So if you plug in 0, that goes away, and then you just get the b, the 5. So 0, 5 is your y-intercept. Okay, So that's your first step. Then identify the slope. So the slope is just this one. So m, it's the coefficient of the x term. That's the way you should think of it. So you put the negative either on top or bottom, but not both. And remember, it's rise over run. Okay. Plot the point representing the y-intercept. So 0, 5. Now we're going to use the slope to get the next. Use rise over run to determine at least 2 more points on the line. So if I do rise, that's up 2. Run is -3. 1, 2, 3. Right? So I was using this one. Or I can do down 2, -2, and then right 3. Down 2, right 3. Okay. So again, if I go down 2, that's my rise, which is actually going down, and then my run, that equals 3. So down 2, right 3, down 2, right 3. Or I can switch the signs and go up 2, left 3. Okay, so either way. And then now you just draw the line that goes through all those points. I like to do as many that will fit on my graph. So technically you can just do the y-intercept in one point. But again, if you want the graph to be a little more accurate, you do a few extra points. How come it's not grabbing? See if this will work. And then you make your graph just a little bit more accurate. Graphing a function using transformations. Okay, so another option for graphing is to use transformations of the identity function. F of x equals x, or y equals x, right? So from earlier, right, we practiced taking a function and you can transform it by shifting it up, down, left, right. You can also use a reflection, a stretch, or a compression. So honestly, me personally, I never do it this way for a line. Using the slope-intercept form is the best way, in my opinion. But just the book shows it, so I'll show you real quick. I'm going to show you the graph that they have here. All these different beautiful colors on here to kind of show you all the difference. To me, it's kind of silly to do it this way, but anyway, you can if you wanted to. So let's see. The purple one here is the original y equals x, or f of x equals x. Same thing. So notice it's again called the identity function because the input and the output value are the same. So 0, 0, 1, 1, 2, 2, so on. 3, 3, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so on. So you get that purple one. Now if you want to vertically stretch it by a factor of 2, that's this one, you take the y coordinate, which is 2, and times it by 2, and you get up to 4. And that vertically stretches it. So if you're here at 3, you take the y coordinate, stretch it by a factor of 2. So 3 times 2 is 6. And then you get this whatever bluish color this one is. Okay, so anyway, you can do the stretching and shrinking. If you do -2, the negative part is going to flip it over the y equals x, the x-axis. So you take the y coordinate times negative and then stretch it to get to -2. And that'll be this red one. Again, me personally, I never do it this way for lines. I just slope-intercept form. And this graphic shows the nice vertical shift. So again, we start out with the identity function y equals x. And if you want to shift it up 2, it would be y equals x plus 2. And that's this color here, this orange color. Okay. And then the red, that would be shifting it down 2. Again, like I said, I don't ever use the transformations for a line. I think it's the slope-intercept is such a powerful way to graph these. I don't need these techniques. But I use these transformation techniques for every other kind of graph. So I do want you to learn transformations, just not necessarily for lines. Okay, having said that, we'll still do one using this technique just so you see it. But again, I never do it this way. So given a linear function, use transformations to graph a line in the form f of x equals mx plus b. So graph the base graph, y equals x, so that's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so on. So this is my base graph. Okay. Then vertically stretch or compress the graph by a factor of m. So here are m's 1/2, so we're going to take each of the y coordinates and times it by 1/2. So we're going to cut these in half. So let's see, 3 divided by 2 would be 1.5, 0.5, 4, so on. And then we're going to shift it up or down 3 units. So that's going to get shifted down 3 units. So each of those points will get shifted. Here, let's do this using different colors. Okay, so this would be my transformed one. The first stage. This is the compression. I'm just going to do it as a dotted line. Now we're going to take that and shift it down 3 units. Let's do this one in this purplish color. So down 3 units, down 3 units, down 3 units. That's all we need because 1, 2, 3, because remember 2 points determine a line. 1, 2, 3. If you do more, it just makes your graph a little more accurate. 1, 2, 3. Okay, and let's do that. We'll do that in solid purple. So that's the line we want. The transformations. So again, to me that's a little, takes a little more time than doing. You're going to do the y-intercepts -3, the slopes 1/2. So up 1, run 2, up 1, run 2. Okay. So again, personally I never use transformations for lines, but again I use it for everything else. Writing the equation for a function from the graph of a line. So the technique, you're going to identify the y-intercept, choose 2 points to determine the slope, substitute the y-intercept and slope into the y-intercept form. Thought we did that already. Okay, so let's see. Match each equation of the linear function with one of the lines. So let's look at example 14 here. So for this line marked with the red one with the 1, the y-intercept is 3. So let's see, 1. Y-intercept is 3. Okay, so that would be 3. Now the slope, we can, since we have the graph, I'm just going to count. It's rise over run, which is 2 over 1. So that's just 2. I'm not even going to write anything down. So that's equation 1, and then we're going to put it in function notation. So we got 2x plus 3. So that's A. Okay. And then, or I guess I should put 1 here. Huh? Okay, and then this one, so we can do it either way. We can go look for the one. So I was just reading this. So if I want this 3 here, the y-intercept's -3. So if I want the 3 here, the y-intercept is 3, -3, sorry. So that'd be -3, and the slope is up 2 over 1. So that'll be 2x minus 3. So 2x minus 3, so that's 3. Or, so you can figure out the equations of the graph, or you can just say, all right, it's at plus 3. The slope is down 2 over 1. Down 2 over 1. So that's 4. And then this must be 2. So let's just double check it. 1/2. So up 1, right 2. So that's 2. Finding the x-intercept of a line. X-intercept. The x-intercept of a function is the value of x when f of x is equal to 0. It can be solved by the equation 0. So you're going to plug in 0 for the f of x or the y. And solve the equation 0 equals mx plus b. Okay, so again, if you think about it for a second, this is the y-intercept. I'm just going to write y-int is 0, some number for y where it crosses the y-axis. Now if I want the x-intercept to get to this point, I'm going to go up 0 and then over however many x. So it's going to be a and then up 0. So the y-coordinate's 0, but the x-coordinate is whatever where it crosses. Okay? So for the y-intercept, it's 0b, so you put in 0 for x, solve it for b. And the x-intercept, you do it the other way around. You put in 0 for y and solve it for x, which typically we write a. But anyway, so we're going to solve this equation. Another term here is we want to find the 0 of the function. What x value makes f of x equal to 0? So we put 0 in for f of x and solve it for x. So you're going to add 3 to both sides, or just move it, change the sign, remember that shortcut. And then you're going to multiply both sides by 2 to cancel the 1/2. Right, those cancel. You get 1x, which is just x, and 2 times 3 is 6. So my x-intercept is equal to 6, 0. So I would go to 6 on the x-axis, put a dot there. Describing horizontal and vertical lines. So horizontal and vertical lines. Lines can be horizontal or vertical. A horizontal line is a line defined by the equation in the form f of x equals b. So if you think about slope-intercept form, f of x or y is mx plus b. So if the slope is 0, right, if it's constant, so a horizontal line, let's say right here, we do this horizontal line. We're not going to go up or down, we just stay flat. We get this horizontal line. And the equation for that horizontal line is going to be given by, now if we think of slope-intercept form, we already talked before, the rise is 0 and run is 1, 2, whatever. So the m is just going to be 0 over any number, which is 0. So a constant function, the slope is 0, doesn't go up or down. So if I plug it in here for 0, 0 times x is just 0. And basically that goes away. 0 plus b would be just b. Okay, now b is where it crosses the y-axis. So the equation of this line would be simply y equals 3. All right? Or f of x equals 3. Whichever way you want to do it. So that's what we call a constant function because the output value is not changing. Okay, and it makes the graph as a horizontal line. Now for a vertical line, it's just simply x equals a. So if I had a vertical line, like say, let's go through these points, say 1, 1, 1, 3, what's going to happen there when I try to do the slope between those 2 points, m is going to be, so it's going to be, if the rise is 2, the run is going to be 0, and then that's undefined. It doesn't have a slope. It's undefined. It's not a number. So 0 is a number, but again, it's 0. So we got to be careful. Undefined. This one has no slope, so you can't put it in slope-intercept form. So if we go back to just say, okay, if we're making a table of values, I know that x value is going to be 1, the y value is going to be whatever. So like this is 1, 0. So the equation that describes this situation is x has to be equal to 1. Y can be whatever it wants, so you don't have to list it in the equation. So x is equal to 1. Okay, and that's the form. So vertical line is defined by an equation form x equals a being whatever the x value is for the line. Okay, so the x value has to stay at 1, and then y can be anything it wants. Okay, so let's try 16 here, write an equation of the horizontal line. So you just have to remember that it's not going to be x, like the x-axis that goes horizontally. It's what's the y value where the line crosses. What's the y value? So it'll be y equals, and what's the y value? -4. All right, in example 17, write an equation of vertical line. So again, you have to just remember, if it's a vertical line, it's x equals whatever the x value that the line's going through, right? So the x value for all the points of this line would be x is 7. So x equals 7. In our next learning objective, determine whether lines are parallel or perpendicular. Determining whether lines are parallel or perpendicular. So two lines, in geometry we say two lines are parallel if and only if they are on the same plane and never intersect. Now the way we talk about it in algebra is we think about it on a coordinate plane, and you can see that the slopes are going to be the same, and then they're going to have to be different lines, so they can't intersect. So the slopes have to be equal, and then the y-intercepts have to be different. And I'll show the definition in a minute. All right, and then perpendicular lines, when they intersect, so parallel lines do not intersect, perpendicular lines do. And they intersect specifically to form a right angle, right? That's the definition in geometry. Now what we're going to talk about in algebra is you look at their slopes, and the slopes are going to be what we say are negative reciprocals of each other. So if you look at the slope of the blue one here, well, actually they didn't go far enough here. Let's look at that point and this point. M would be, see, up 5 over 1. And then for the red one, let's find, okay, they got this point and this point. So that'd be 1, 2, 3, 4, 5 for the run and 1 for the slope. So that slope would be, it'd be up 1, left 5. So up 1, left 5 would be negative 1/5. Again, you can see those are negative reciprocals. So you flip it over, change the sign. Here's the definition for algebra. Parallel and perpendicular lines. Two lines are parallel if they do not intersect. The slopes of the lines are the same. So if we have two functions, f and g, f of x is m sub 1, so the slope for line 1, x plus b sub 1, and g of x is m sub 2, x plus b sub 2. So they're parallel if and only if the slopes are equal, m1 equals m2, and if and only if the slopes are, Okay, it says if and only if B1 and B2, if those are the same, we say the lines coincide. Coincident lines are the same line. So to be parallel, B1 and B2 have to be different. If they're equal, then they're going to have the same slope, but they're not going to be two separate lines. They're going to be the same line. Okay? Two lines are perpendicular lines if they intersect to form a right angle. So if we have the two equations, they're perpendicular if and only if. Now here's the test. If you multiply negative reciprocals together, you get -1, right? So M2, slope 2 is the negative reciprocal of slope 1. That's how you read that notation. So for instance, if M1 is, say, 5, then M2 would be -1/5, which is basically the case we just did, right? If this is 5, this is -1/5. And if you multiply M1 times M sub 2, 5 times -1/5, you get -5/5. The 5's cancel, and you just get -1. Okay, so that's the test. If you multiply it together, you get -1. Visually, you can just say, are they negative reciprocals? Sometimes that's not always easy to tell if they're given as decimals. So you want to do this test to see if it gets -1. For instance, if -1/5 was written as a decimal, right, 0.2, and then if you get your calculator, 5 times -0.2 is going to be -1. So if you don't recognize that, oh, that's -1/5, sometimes you might say, oh no, they're not perpendicular. Example 18, identifying parallel and perpendicular lines. Given the functions below, identify the functions whose graphs are a pair of parallel lines and a pair of perpendicular lines. So remember, to be parallel, the slopes have to equal. So let's see, we got 2x, 2x. So F and J are my candidates, and then they have different y-intercepts. So f of x is parallel to j of x. Okay, so f of x, 2x plus 3, is parallel to j of x. Okay, and then these two, so look at for g of x. G of x, the slope is 1/2, and if you did the negative reciprocal, you get -2. So g of x is perpendicular to h of x. And again, you just run the test. So if the slopes are equal, then it's parallel, but you also have to check that they have different y-intercepts, that they're two separate lines. And if the slopes are negative reciprocals, or if you do 1/2 times -2, you get -1, then that's perpendicular. Okay, and our last learning objective, write the equation of a line parallel or perpendicular to a given line. Example 19, finding a line parallel to a given line. Find a line parallel to the graph f of x equals 3x plus 6 that passes through point 3, 0. Okay, so our first step, here's how to find the slope of the function. So if f of x equals 3x, so f of x is equal to 3x, remember mx plus b. So the 3 is the m. So m equals 3. Now my parallel line slope of the parallel line has to be the same. So my parallel slope will be 3. Okay, now substitute the given values in the general point slope form or the slope intercept formula line and then simplify. So now we're going to put the x and y. So for my parallel line, we got y equals mx plus b. We know that m is going to be 3, the same. Now we're going to plug in the x and y that was, oh no, sorry, I was thinking that was the y-intercept. This is the x-intercept. So we plug in the x and y, so 0, 3 for x, and we solve it for b. So this is 9. Subtract 9 from both sides, so you get -9 is b. So now we can write the equation of the line, and it will be y equals the 3x minus 9. And that would be our parallel line. Okay, just to kind of show you a visual of what was going on. So the question had us f of x is 3x plus 6. That's this red line. And they want it parallel to the point, and it goes through the point 3, 0. Right, so we want to go through that point. So we came up with y equals, has to be the same slope to be parallel, and then we found the y-intercept to be -9, and you can see that it goes through that point and it's parallel to the original line. Okay, so our solution would be y equals 3x minus 9. Example 20, finding the equation of a perpendicular line. Find the equation of a line perpendicular to f of x equals 3x plus 3. So again, we want it to be perpendicular. 3x plus 3 would be something like this. Perpendicular through the point 3, 0. So the same point, so we want to figure out what that line is. Okay? So if this slope is 3, our first step is find the slope of the function, right? This is 3. M equals 3. Determine the negative reciprocal. So the negative reciprocal, you're going to flip it over, make it negative. Or if it's negative, make it positive, right? They have to be opposite signs. So this is my perpendicular slope. The upside down t is perpendicular. So M subperpendicular. All right, substitute the new slope and values of x and y into the coordinate plane provided into the equation. Oh, they're using g of x instead of y. Same thing. So we're going to now, I'm going to write y mx plus b. And I'm going to put in my perpendicular slope, which is -1/3. And then I'm going to plug in the 3, 0, -1/3 times 3, y is 0. So this is nice, the 3's cancel. So you get -1 plus b, add 1 to both sides, so b is 1. And then I can write the equation. I'll go ahead and use the g of x this time. G of x for y, the slope is -1/3 x, and then the y-intercept is 0, 1, so b is 1. And then that's our final answer. Okay, again, just to see it on Desmos here, so we got y equals 3x plus 3. Okay, so that's the red one. We want to be perpendicular through the point 3, 0. So we got to take the slope, make it negative reciprocal, so -1/3. So that's perpendicular, makes a right angle, but we want it to go through 3, 0, so we figure out what the y-intercept needs to be, and we said it was +1. And you can see that it goes through 3, 0, and it's perpendicular to the original graph. Example 21, finding the equation of a line perpendicular to a given line passing through a point. So a line passes through the 2 points, -2, 6, and 4, 5. Find the equation of a perpendicular line that passes through the point 4, 5. Okay, so we have 2 points, 4, 5, okay, just a rough sketch, negative 2, 6, and that's going to be our line like that, and then, let's see if I can do that better, not much, but anyway, and then we want the perpendicular line through this point, 4, 5. So first we got to figure out the slope of that line. We don't have to actually find the equation of the line. We just need to find the slope of that line. And then this would be our perpendicular slope, which will be the negative reciprocal. So let's see if we do, so this m, determine the slope of the line passing through the points. That's our step 1. So y2 minus y1, x2 minus x1. So 5 minus 6 over, remember, do it the same order, 5 minus 6, 4 minus a minus 2, which becomes plus 2. So we get negative 1 over 6. So that's negative 1/6. So if I do the negative reciprocal, flip it over, 6 over 1, and change the sign, it'd be just positive 6. So my perpendicular slope is positive 6. Okay, now we're going to use slope intercept form or point slope form. Write the equation by substituting no values. So I'm going to start out with y equals mx plus b. I want to put in my perpendicular slope, 6. I'm going to pick one of the 2 points. Let's just do 4, 5. Oh no, we have to do specifically 4, 5 because it's going through that point. So 4, this point's on the other line, so I have to make sure I use the right one, the 4, 5, and solve it for b. So I get 24, subtract 24, so signs are different. 24 minus 5 is 19. Take the sign of the larger, which is the 24, it's negative. Okay, now I can write the equation. So it'll be y equals m, which is 6, x, plus b, which is minus 19. And that's my final answer right there. And that brings us to the end of this lesson. So again, you want to practice, practice, practice. Do as many of those odd exercises in the end of the section and submit them to Canvas. All right, talk to you later. Have a great day.